Okay, so bear with me here. I've sort of concocted this jankety device to try and prop my phone up, so I'm hoping that this is going to work. But the idea is here, if you've done the reading, you came across the equation, the Newton's universal law of gravitation equation. And it says that all masses in the universe are attracting all other masses with a force of gravity, and that force of gravity is going to be equal. The force of gravity between any two masses is equal to this expression. This is actually mathematically not a difficult thing to deal with, which is why we're doing it today on an e-learning day. The only thing that is difficult about it is using your calculator to deal with big numbers. And some of you may have more experience with this than others. I leave you up to your discretion about how much of this video you need to watch, but at least watch as I work out the first problem, and then after I do the first problem, you can stop if you feel like you got it. All right, so let's imagine an example problem. So let's say that a 10 kilogram person, that's a really light person. Let's say a 70 kilogram person stands on the surface of the earth. Find their force of gravity. And I see that I am running off the page, but okay, that's the idea. All right, so we got a 70 kilogram person standing on the surface of Earth, find the force of gravity. So here's my Earth, and here's going to be my person standing on it. And we know that if we're looking for using this equation, by the way, I'm making this more difficult than it needs to be because we know that we could just do this, right? We could just do Fg equals mg, but for the sake of my problem, let's not do it that way. Let's use our new equation, Fg equals g m1 m2 divided by r squared. Okay, what do we know? Well, we know g is always the same. You found in your book that it's 6.67 times 10 to the negative 11th Newton meter squared per kilogram squared. We know the mass of the person, and it doesn't matter which one's M1 and which one's M2, but I'm guessing that the person we're going to say is M2. So the person has a mass of 70 kilograms. Now, the mass of the Earth, I didn't bring my book over here. Pardon me for 1 second. So this is something that would be I'd have to either give you the mass of the Earth, or it's also in the front part of your book, and I'll give you in class a paper that has all these constants in it. But the mass of the Earth, if I look it up in my book here, is 5.98 times 10 to the 24th kilograms. And what's this r going to be? So remember, the radius is it's the distance between the center of the two objects. So that's basically going to be the radius of the Earth, because this guy is really so small that we shouldn't have to matter how far above the Earth his center of mass is. Basically, this is going to be the radius of the Earth, which is another thing I would look up in the book. And I would find that the radius of the Earth is 6.38 times 10 to the third kilometers, but I need it in meters, so I'm going to say that's 10 to the 6th meters. Okay, so again, setting this up is fairly straightforward because it's just a matter of plug and chug. So I'm going to plug it in real quick, but then where this gets tricky is just making sure that we know how to use our calculator. So 6.67 times 10 to the negative 11th times 5.98 times 10 to the 24th times 70 divided by 6.38 times 10 to the 6 squared. Okay. So if you've never done scientific notation on your calculator, it's not difficult, but there's just a few things you need to know. So what you're looking for in your calculator is you're looking either for a button that says EE, or sometimes it says EXP, I'll show you in a second how to do it if your calculator doesn't have one of those. But if you have one of these buttons, what you're going to do is you're going to write, okay, 6.67, and this E button stands for times 10 to the something. So 6.67 E negative 11 is the same as 6.67 times 10 to the negative 11th, right? These are equivalent things. So I can say that times 5.98, again, we're going to do E, 24 times 70 divided by 6.38 E6. And one of the things that a common mistake is to forget to square this thing on the bottom. So I have to make sure I'm going to put that in parentheses and square it. And I get an answer that the force of gravity is 685.9 newtons. Now, just to double check, let's see if we did it the easy way, would we have gotten the same answer? So if I come over here, Fg equals mg, and I say 70 kilograms times 9.8 meters per second squared. .686. So you see, other than a rounding difference, Newton's universal law of gravitation works. So when do you have to use Newton's universal law instead of this easy equation? Well, it's in the name. Newton's universal law of gravitation works anywhere in the universe. This equation works on Earth, right? So when you're on Earth and you're on the surface of Earth, you can use this equation. But when you're anywhere else in the universe or when you're farther away from Earth, you have to use this equation. Okay, real quick, if your calculator does not have the EE button, let me show you the other way to do it. You essentially, if you're doing it the other way, the other button that you're looking for, if you don't have an EE button, you're looking for one of these that says 10 to the x, or sometimes it says times 10 to the x. And you're just going to write the equation exactly as it appears here, but you got to be very careful about putting your parentheses in correctly. So I could say 6.67, and then I'm going to go to 10 to the x. So 6.67 times 10 to the negative 11th. Then I got to make sure to close that parenthesis and close the parenthesis of the whole thing. So that times 5.98. Oh, I'm not doing it that way. So again, I got to be careful with my parentheses. So 5.98 times 10 to the 24th. Close it. Times 70 divided by, and this is where the parentheses are keenly important, because if you forget to put the parentheses after divided by, your calculator chokes up. So 6.38 times 10 to the 6th. Close both of those, squared, and I get the same answer. So your calculator will have one of these two buttons on it. It might have both like mine does, but it should have one of these two buttons. So if you're good with that, you can go ahead and stop this right now and go on to the Check for Understanding quiz. All it is one of these problems, making sure you know how to use your calculator. If you would like another example, just stay tuned. I'll give you another example here. So we'll talk about the force of gravity between the Earth and the Moon. So there's my moon going around my Earth. Okay, so I would have to tell you these things, but it turns out that the mass of the Earth is 5.98 times 10 to the 24th kilograms, like we just said. The mass of the moon is 1.74, nope, sorry, looking at the wrong thing. It's 7.35 times 10 to the 22nd kilograms. And the Earth-Moon distance on average from center to center is 384 times 10 to the 3rd kilometers. But again, we got to be careful because kilometers aren't helpful to us. We got to go to meters. So there are 1,000 meters in a kilometer. So if I multiply that by 1,000, that would just be 10 to the 6th instead of 10 to the 3rd. All right, so Fg equals G M1 M2. I'm losing you again. Let's come over here. G M1 M2 divided by R squared. What am I missing here? Okay. G we know is 6.67 times 10 to the negative 11th. M1 is, it doesn't matter which one, but I'll say the Earth is M1. I'm losing you again. All right, and the moon we just said was 7.35 times 10 to the 22nd divided by 384 times 10 to the 6th. Again, make sure to square it. Oops, sorry, that should be a squared. So again, when you do your calculator, let me get it so that you can see here. I always prefer, if you have a calculator that has one, to use the EE buttons, because then you don't have to worry about, your calculator is smarter when you deal with that. You don't have to worry about parentheses as much. Times 5.98, 24th, 7.35, 10 to the 22nd divided by 384 times 10 to the 6th. And the cool thing is, even with this, I don't actually have to put the bottom one in parentheses if I'm using the e's, because your calculator is smart enough. If you're using the other method, you do. So there we go, 1.98, and you'll notice that I'm given this as a, in that same notation. So the way that I would write this is 1.99, I'll go ahead and round that, times 10 to the 20th right here. And this is a 4, so it's in newtons. Okay. If you have questions, please feel free to email me. Other than that, go ahead and take the Check for Understanding quiz.